data structures in R. So data structures are the backbone for handling, storing, and manipulating data effectively. Data structures allow users to organize complex data into manageable formats, enabling them for efficient data processing and analysis. Primary data structures in R are vectors, matrices, array, data frame lists. So we are going to take these ones one after the other. Then after that, we will go to RStudio and practice them. Okay. So what are vectors? Vectors are one-dimensional arrays that can store data of the same data type. So if you are storing numeric, you store numeric numbers only. If you are storing characters, you store characters only. If they are logical data, you store logical data only. Those are vectors. Then we move on to talk about. So vectors are like the basic and commonly used data structure in R. They are basic and commonly used data. They are often referred to as the building blocks in R. They are often referred to as the building blocks in R. So matrices move ahead of vectors, right? Matrices move ahead of vectors to say that matrices are two-dimensional arrays where data is organized into rows and columns. Columns. Unlike vectors, which are one-dimensional, matrices can store data in a grid format, allowing for the representation of the data sets that have both rows as observation and columns as variables. It can also change depending on what you want to do. So matrices are widely used in quantitative research, and there are times where some packages that you download, they will demand that you convert your data structure to a matrix before it can work. All elements in matrix must also have the same data type. That is, if they are numeric, they have to all be numeric, and if they are characters, they have to all be characters. You cannot miss them. Alright, so now let's move on to talk about arrays. Arrays extends the concept of matrix to a higher dimension, allowing for data storage in more than 2 dimensions. An array in R can have 2 or more dimensions, right? Making it suitable for representing complex data sets. Arrays are generalization of vectors and matrices. That is basically what we say. They are generalization of vectors and matrices. Data frames. Data frames are one of the most common used data structures in R for handling tabular data. Unlike matrices, data frame can store different data types. So you can have different data types. You can have characters, numeric, logical, in different columns. Remember, you can have them in different columns, making them ideal for data sets that include both quantitative and qualitative variables. Data frames are similar to spreadsheets like Excel spreadsheets, or even SQL tables. So the last one that we will talk about is lists, right? Lists are wonderful. They are wonderful. If you know how to use lists, you can be able to export a lot of things from R to a perfect fit Word, Excel, or what have you. Most of the time people complain that they are not able to, when you do analysis in R, it's complex to be able to export the data, unlike other statistical analysis where you can just export your data to Word. But if you know how to use lists, you can be able to arrange your data perfectly, arrange your results perfectly, and export them into Word or a format that you want. So we are saying that lists in R are versatile data structure that can store elements of different data. It's including vectors, matrices, data frame, and even other lists. Unlike vectors and matrices, which require elements to be in the same data, lists can contain a heterogeneous collection of elements, right? So that is the idea of lists. So we are going back to our R to perform this example, then call it a day. Okay, the examples of vectors are what we did earlier, so I will not go back and talk about do examples of vectors. All that we've been doing are vectors where you see the C combined, they are all vectors, because they are one dimensional. So let me move quickly to talk about matrices. So matrices are two-dimensional and they have what? Rows and columns. Rows and columns. So as you can see, I'm creating a matrix L1 where I have 3 rows and 2 columns. Where I have 3 rows and 2 columns, and we are saying that it should be, the creation should be by row, as in the rows should be created, the rows should be created before the columns, right? You can also say that by row should be false, and with that the columns will be created before the rows. That is the difference between L1 and L2. That is the difference between L1 and L2. So let's quickly run the two and see what we are talking about. See, so when you look at the results of L1, we can see that L1 has what? Chi, Ga, Ewe, Fanti, Hausa, Gunja, right? Now let's go to L2, where we, oh, sorry, we cannot assign 2 to an object. You cannot assign a number to an object unless it is 2 and the letter or something. You cannot just assign that. So L2, see that L2 started filling the matrix by the column, right? So 3 came first, then Ga, then Ewe, before we went to column 2 where it talked about Fanti, Hausa, Gonja, right? So that is what we talked about, using the by row and true or false. Also, we can use a sequence, right? So we are saying that it should L, which is line 101, should have create a matrix of 4 by 5. Row should be 4, column should be 5. Then it should be 1.2. It should be 1.1:20. That is between 1 and 20. Right. So when you do that, you can see that it's just 1, 2, 3, 4, 5, 6 up to 20. And see, this time around we didn't specify anything, right? And it started filling the column first before the rows. It started, so automatically I will always fill the column first before the rows, unless you specify that I should fill the row first. You can also coerce a vector into what? A matrix. You can also convert a vector into a matrix. See, as at first we used to always use this to create what? A vector, right? We used to always use this to create a vector, but because we have matrix here, this will not be created as a vector, but will be created as a matrix. And because we have the n by 2 by 3, the number of rows should be 2 and the number of columns should be 3 because of that. And you can also use print. See, at first I was not bringing the print at this time around. Well, this is a tutorial. There are dimensions that I'll be doing. There are times where I can even put the cursor there and still run. They are all the same. And there are times where you can combine vectors, right? You can combine vectors. So v is a vector, x is also a vector. V is a vector and s is what? S is also a vector. And with that, we are telling her that I should use C bind. C bind is column bind. Column bind. So you should bind them by columns. And R bind is row bind. You should bind them as rows. So when I do that, we are getting a warning message because the vector created is not of the same size. So when you look at from 10 to 15, it has what? 6 vectors, right? 6 numbers, right? 10, 11, 12, 13, 14, 15. So let's look at it. So 10, 11, 12, 13, 14, 15, which is 6. And x is what? X is 5. So because of that, when you use the when you combine them in a matrix, well, they have to be of the same length. Additional 1 will be created automatically to add it. If you think it's not right for you, what you have to do is that you can also convert. You can also reduce it to the same size or not. So that is what this warning message is trying to tell you. It's trying to tell you that the number of rows is of the results is not a multiple of a vector length. That is, they are not the same of the same side, right? So this is a tutorial, so you have to bring some of this so that at the end of the day, when you encounter them, you'll be able to understand. So we can construct a 3x4 vector by 2 arrays, right? 3x4 vector by 2 arrays. 3x4 vector by 2 arrays. We want 2 different arrays, right? Where is A1? 2 different arrays, right? So 2 different arrays. So let's move quickly to data frames and lists, right? Data frame, as mentioned earlier, are the most common data structures in R for handling tabular data. So you can have different types of data types in a data frame, whether numeric, characters, among others. So as you can see here, we have numeric. So let me even add LL to this one so that it will be seen as integers. We can add 0.86. So when we check, we are going to have this, and when we check the class, so these are all fictitious data, they are not real. So see that they are telling us that it's what? A data frame, right? They are telling us that it is a data frame. So these are the columns. You can view the data frames too. You can view them. With data frame, you can view. You can use view into brackets, then the name. So this is it. This is how it looks like. I use view into brackets, gamma data, to view a data frame. Then the last one is the lists. The list, as we said, combines a lot of things. It can include vectors, it can include matrices, data frames, and what have you. Okay, can just be adding them. So you can be adding all the things you've created as lists. So I have a list. This is a vector, right? Or I can have a list that combines So that is that for today. If you have any question, let me get to know. If you have any problems, you can DM us. You can send a comment. You can make your comment. Let us know if there are parts you like us to, if there are videos you like us to do on certain topics, then you just leave them in the comment section. That will help you out. Thank you.